Hey everyone, welcome back to the channel. So now we are going to solve a problem from Spoj, whose name is Eko. And let's move to the problem statement. And it is saying that lumberjack Mirko needs to chop down m meters of wood, and it is an easy job for him since he has a nifty new wood cutting machine that can take down forests like wildfire. However, Mirko is only allowed to cut a single row of trees, and Mirko's machine works as follows. Mirko set a height parameter h in meters, and the machine raises a giant saw blade to that height and cuts off these trees parts higher than that height. Of course, trees not higher than h meters remain intact. And Mirko then takes the part of that trees were cut off. For example, if there are a row contains trees with heights 20, 15 and 10 and 17 meters, and Mirko raises his saw blade to 15 meters. So from the tree 20 meter, he will get 5 meter. From 15 meter, he will get 0 meter. 10 meter tree will remain intact, and from 17th meter tree, he will get 2 meters. So total he will get woods of length 5 meter from 20 meter tree and 2 meter from 17 meter tree. So he will get 7 meter of wood in total. And Mirko is ecologically minded, so he doesn't want to cut off more wood than necessary. That's why he wants to set his saw blade to as high as possible. So help Mirko to find the maximum in integer height of that saw blade that still allows him to cut off at least in meters of wood. So this is the final statement that we need to solve in this problem. So if we simplify the statement, here we have given some trees lengths, and it has also given that a height. We have to find the maximum integer height m by which we can get at least m meters of wood. Okay. And here is the input. N can ranges from 10 to power 6 and m is 2 into 10 to power 9 meters. So we have to find an optimized way to solve this problem. So just let's take this first case as input. Yeah. So this is n and this is m, and these are the heights of trees given. Okay. So what will be our approach? Our approach will be to find maximum integer height by which we can get at least m meters of wood. So how can we do that? So just first identify where can be our height. So our height can be in between 0 and maximum height of this tree. So h can be between 0, 1, 2, 3 up to maximum height is 20, so up to 20. So we have just identified our search space. This is our search space, and on this search space we will apply binary search. So if we just don't want to think about binary search, it's okay. We can apply linear search here, but in this case the complexity will be big of size of this, and the size is max of ARR. Let's say this ARR, so max element if we apply linear search here. And to apply binary search, the time complexity will changes to big of log max element. Hope you understand this. So and this is also sorted. So we can easily apply binary search over this range. Okay, so let's apply the binary search here. Let me erase this. Okay, just take one low and high, and third will be mid. At the beginning, our low is pointing to 0 and our high is pointing to 20. So just write on this 0 and 20. So our mid will be 0 plus 20 by 2, which is 10. And now we will look if 10 height is possible or not. So just take this. If we choose height as 10, so how many woods we get? So if height is 10, from 20 meter we will get 20 minus 10, which is 10 meters of wood. Again, for 15 meter we will get 5 meters of wood. From 10 meter we will get 0 meters of wood. And from the next 17 meter we will get 7 meters of wood. Okay. And if we visualize this, if this is the height of tree and machine is set at this place, if this is the height of machine, then it will cut this, and this is our wood. Just for understanding. Okay, so if height is 10 meter, we will get total of 22 meters of wood. So yeah, this is, yes, this is our M here. So this qualifies. 22 is greater than or equal to M. Yes, then our height can be 10 meter. Okay, just make a variable answer. And initially it is 0, and after applying this operation, our answer will changes to mid, which is 10 here. Okay, again, if I choose height 10 meter and we need to, as suggested in question, we need to maximize our height. So we will look forward to maximize our height. So just shift your low variable to mid plus 1. So in this case, our low will changes to 11, high will remain same, and the new mid will be 20 plus 11 by 2. So it will be 15. 31 by 2 is 15. Okay, so if new height is 15, what will be our woods collected? So just from the 0th element, 20 woods collected will 20 minus 15, which is 5. From the next 15 minus 15, which is 0. From 10 meter tree will remain intact, no disturbance, so 0. And from this 17th meter we will get 2 meters of wood. So our wood collected is exact 7 meters, and M is also 7. So yeah, this is possible answer also. So our answer will changes to 50. Again, in the next iteration, if 15 is possible, we need to maximize it. Okay, so our low will changes to 16, high will remain same 20, and new mid will be 20 plus 16 by 2, which is 36 by 2, 18. And now we have to look for 18, how many woods can we collect. So from the 20 meter we will get 2 meter of, let's change the color here for better understanding. Yeah, from the 20 meter we will get 2 meters of wood. From 15 meter 0, from 10 meter 0, from 17 meter 0. So our total woods collected is 2. So is this possible answer? No, we have to at least collect 7 meters of wood. So this is not true answer. Okay, so 18 is not possible, these two are possible. Okay, so we don't need to update the answer variable. So if 18 is not possible, any values greater than 18 will also not satisfy this case. Okay, So we need to just look back. So in this case, we will shift our high to mid -1. So our new high will be 17 and low is 16. So the mid will be 16. 33 by 2, yeah, 16. So for 16, we will look for how many woods can we collect. So from the 0th element, 20 minus 16, which is 4 meters of color change. Yeah, from first from first tree we will get 4 meters of wood. From second tree 0 meters. From third 0 meters, and from fourth 1 meters. So total wood collected is only 5. This will also not satisfy our answer. So if 16 is not satisfied, then any values more than 16 will also not valid. So again look back. Then high is also shifted to 15 and low is at 16. So in this case our low exceeded the high value. Okay, so we just stop looking and value inside our answer is our final result. So in this case our answer is 15. So hope you guys understand this, what I am doing here. Okay, just yeah, just code this solution. So okay, I am doing in C++. If you understand the intuition behind this problem, you can also code in any language of your choice. Okay, bit slash. These two are for just input. Now inputting our n and m and creating a vector of size. Let's denote our vector with name arr of size in, and now inputting the array elements in our vector. Okay, and from now we will just implement our solution. So let's create low and high. Low, which is initially set to 0, and high is set to 20, which is our maximum element of arr. Yes, this is arr. Okay, low is at 0, high is at max element of arr, which is arr dot begin. Yeah, and also let's create our answer, and initially it is at 0, and now applying binary search while low is less than or equals to high high, and now creating our mid and setting its initializing its value, which is low plus. I am doing this just to prevent overflow. Let's create here long also. and this is my function which will look for if the possible mid is valid answer or not. So just pass it m mid and our array, and this will return a boolean type data which will store in flag variable. And now if it will return true, then it is a possible answer. So in this case we will store this answer in, we will store the mid in our answer every time we update, and changes our low to mid plus 1. Otherwise, if this is not a possible answer, we will look behind, which is setting our high to mid minus 1. Yeah. And now we have to code our words collected function. Okay. Our first parameter is m. Our second parameter is mid. Let's denote it with height h. And third is vector of type long, and name it ARR. Okay. So this function is basically doing nothing but doing this operation, just finding the difference and summing it all. So let's create a variable sum and initialize it with 0, and now iterating over our vector. Yeah, here I am doing maximum of 1 allele, which is basically long into 0, which will give long. Okay, maximum of 0 or it minus h. This is because if our let's take 18 case, if our it is at 10 and h is at 18, so in this case it will give negative value, and we want only value from 0 to positive difference, which is, so in this case this function will give, this function will return 0, otherwise it minus h, just to prevent the maximum negative value. And now checking if sum is greater than or equal to m, we will return true, otherwise return false from our words collected function. And we have done all this. Okay, finally just printing our answer here. Okay, so let's take this case and run this. Hope this will pass. Yeah, this gives 15, which is our required answer. And let's run this on another case also. Yeah, 36, which is also true. So just let's take a look at this time complexity. So here This is basically iterating over the ARR and summing it. So here time complexity of this function is, so let's go down. Okay, time complexity of this function is big of n, where n is size of our array, and for this binary search, our time complexity is big of log what? Big of log max of the max of element inside ARR, because we are iterating over the low is 0 and high is set to max. So our time complexity is big of max EL. Let's note. Yeah. So binary search time complexity big of log max L, and woods collected time complexity big of n. And for every iteration, for every iteration we are calling this function which is big of n. So the whole time complexity of the solution comes out to be big of n into log max element, and space complexity is constant because we are not using any extra space. So hope you find this helpful and also understand this. If you don't understand this, just look at this part, and let's submit this solution to the SPOS. Ending it to our C++ and pasting the entire code, and let's submit it. And waiting for compiling. It's taking too much time. Running on 9th test case. Yeah, it's got accepted. You can see here. So hope you guys find this video helpful. If you like this content, please don't forget to subscribe to this channel if you are new to this channel. And if you find this video helpful, please leave a like. And yeah, that's all for this video. See you in next video.